All right. We just had an amazing session, and we're leading right into a new one with Alexander. We're going to be going over stateless DANE. I am very excited to learn more about this. I think I hear the term a lot, but sometimes it could be tough to understand. So thank you so much for the time, Alexander. I'm going to go ahead and shut up now and let you take the stage.
Okay. Hi, everyone. Hi, Alex. I'm Alexander Shevtsov. I'm an independent developer who sometimes contributes to the Handshake project. And this evening, I would like to say some words about Stateless DANE project. And it might be a bit technical, might be a bit boring. I didn't really know who would be the audience, so I prepared some background, maybe some things that you have already heard for thousands of times, but still. So let's go. Let me share my screen. The entire screen, I guess. Okay, I have a tiny presentation. So I will be talking about Stateless DANE. My plan is to have a small showcase. What is that? How it works from the user perspective, and then I will speak about its background and why it has its background, its design patterns. So with some theory and some technical details. Okay, so if to speak shortly, Stateless DANE is an application which allows to browse Handshake websites in a secure way, so over TLS without a need to have a constant connection to an SNSD instance. To show you how it works, I have my Firefox that currently shows nothing when I'm trying to browse a Handshake website. I have a SANE, which has some weird parameters added. I run it, and if I don't catch a bug, that is usually happens when you try to present something, the website should open, and I have a certificate that is provided by this Stateless DANE, and I don't need to have a blockchain node, and I don't need to have a running SNSD instance, and I need only to retrieve 3 roots once in a day, and I will speak about it a bit later. So this more or less is a showcase of how it works. So it's simple running application, which behind the scenes runs a local proxy server and substitutes a certificate for some Handshake website if it complies to the protocol. Let's start with a lot of theory. So we browse websites, we have applications, we have computers, and these computers they ask other computers to get some information. Then they send this information, and computers are located in different parts of the world, and they need to somehow to address other computers, and to do this, they utilize the protocol, which suddenly is called the Internet Protocol, and that was developed very, very long ago, and which allows one computer to address the other one and to route the message to that other computer. And the internet is not pairwise connected, so you don't really have a connection to the destination computer, and so you should have some kind of routing system that bypassing some intermediaries sends your message to the needed computer. And it is done by assigning the IP addresses to those computers, and so behind the scenes, computers, they just have addresses that are just numbers, and they communicate with each other via these numbers. And we humans, we are not particularly good on remembering numbers, entering them, especially when they are constantly changing. So in order to effectively browse websites, people have developed the DNS name system, which effectively translates human readable names into IP addresses that can be further utilized by computers and to retrieve the needed information and to send it. So DNS was devised like 30 years ago, and it uses a server-client model. It's hierarchical. That means that there is a distinction into domains of responsibility. There is some parent responsible computer, parent zone that delegates the translation of its child zones to other computers, and so it's distributed and hierarchical. When DNS was constructed, it was more about usability and operability, and not about security, because at the time the internet was a far more friendlier place than right now. So effectively, when you try to browse some website, you ask a DNS server a question like, what is the IP address that corresponds, for example, to my domain, and DNS server asks other DNS servers, and until the responsible for this domain server responds. So there is a chain of messages, and at some point, those messages can be corrupted or can be maliciously altered. So there is no underlying layer of security there, and that's why people have constructed an extension of it that is literally called DNSSEC, so domain name system security extension. So more or less, it's just the idea of signing all the messages of DNS servers by some public keys and providing this data. So when you ask a server what is the IP address, the response would be signed, and the parent response also would be signed, and so on, until you have a chain of signatures that goes until to the root zone. The private keys for the root zone that also is needed to verify the chain of messages has a special ceremony to generate it, to regenerate it, and it's more or less stored securely by some internet organization, not sure what is its name. And so by using this DNSSEC protocol, it's possible to be sure that an IP address that we want to open really corresponds to the website that we want to browse. So there is no way to fake this IP address, and you will not go to a fake computer. However, it's not enough for a secure communication between computers, because on the underlying level, there is no inherent encryption of packets. So when you browse a website using HTTP connection, your message can be seen by everyone and can be altered. However, of course, we can use the same idea of just to have some public-private key pair and to sign all messages that are going from a client to a server. So, for example, if you open google.com, you somehow know it's public key. You encrypt your information with this public key, sent to them, and so it decrypts and gives you a response. And this response, for example, is signed by your public key. The problem with that is someone in the middle can provide his own public key in place of the Google's one, and you have no way to identify it without any additional extensions. So basically, we want to have some tool to be able to identify a public key with some party, with some entity. And one of the solutions to this problem is to have a certificate authorities. Certificate authorities are some entities that create certificates for some parties that literally certifies that a given party has a given public key, and when you open a website, you can verify that the public key is really from the party. The problem with certificate authorities is that they are centralized, that they might behave badly, and so they are. So, for example, your browser has supplied certificate authorities and their public keys that come with your browser, with the operating system, and that is not very decentralized way to solve this problem. Okay, and the other problem is that they have a universal domain of responsibility. That means that any certificate authority can issue certificates for any party. So they don't have any kind of bounds that I give certificates only to these websites or those. And so if a badly behaving authority can issue a certificate for any website, and it might cause a lot of damage. Another approach to this problem of middlemen is actually to, okay, so it's an issue of certificate, which is not that interesting. Another approach to the problem of the middleman is actually to store public information in the DNS data. So it is called DNS-based authentication of named entities, and it literally allows to store information about websites' public key directly in the DNS records. However, it's not widely adopted by browsers because they say that it adds some latency and that DANE authorities and DNSSEC authorities that they use too weak keys, and that's why they don't adopt it as long as they have other option, namely just certificate authorities. So in order for DANE to work, there are needed two things. Well, it's just information about the DNSSEC chain from the record that stores the public key of some domain up to the root zone, and some kind of proof that this information is up to date. This can be applied directly to Handshake, and in this case, both of these pieces of information, they come from Handshake resolver, which validates, which extracts DNSSEC chain data and validates that this data corresponds to the current state of the blockchain. However, the problem with that is you need to have a Handshake resolver that has a connection to a blockchain and can take data from it and verify that it's really the current state. SANE, so SANE, short for Stateless DANE, it is an extension of DANE, which does not require this connection. Instead of this, it expects the certificate itself to have these two pieces of information, to have DNSSEC data and to have some information about blockchain stored in the certificate. And it does not require an instance of HNSD, and it has to synchronize with the blockchain once a day to pull some data, which takes how we saw, not here. Okay, so it takes about, I don't know, 5 seconds, like so. The Stateless DANE, it expects this certificate to have DNSSEC chain, which is just messages from DNS servers and about the corresponding child and parent zones, and also an Oracle proof. Oracle proof is a tiny piece of information that stores current data about the blockchain state, and it can be stored in certificate. It's like several hundred of bytes, and it's very easy to verify. To have some kind of reference point, it uses the tree root that is one of the block headers from the blockchain, and it is updated like every 6 hours. So we have around 40 blocks every. You have 43 new tree roots every week, and so there are 3 parts to be compliant for SANE. It's the server part, so the server part which generates the certificates that can be used by SANE. It has to be updated once from time to time. And there is a tool to do it automatically. And I've been working for the client side, namely the client that intercepts the connections to website and substitutes it with the certificate that after the with a non-certificate after the validation of the data from SANE. There is also an extension of this idea because as we don't really need to trust anyone because we have our own tree roots, we can use some external proof services that provide information about blockchain and about DNSSEC data. And as long as we can verify again the proof against a given tree root, we can trust these websites. So there is a Handshake. There is a server for this proof service, which is done by Handshake community, and from one of the plans is to make it more reliable, to have some management to it. Sorry, to have some load balance to it and to make it more reliable. From the other stuff, there is also a fingertip. It's a bit more user-friendly way to use the SANE. Actually, it's just a plug-and-play application with all the details set to default ones, and you just run fingertip. You have a tiny icon here, and you can look that current state that my resolver is ready, and browser is using fingertip, and the same way I can access any website that has correctly set up TLSA record. So namely, it just complies to the DANE protocol. Well, current state of the implementation is that we have running Linux build, we have Windows build, and I think we are waiting for signature for macOS build. And so after that, there will be, I hope, a merge from the pull request, and it will be available to public. This more or less everything I wanted to say and to present. And of course, I would like to answer the questions. And I want to say thanks to Rizvik, to Eric, and to Hassan, and to Nodor Shkuselidze. So for incentivizing this project to have some technical help and to have a Go implementation of verifying Oracle tree proofs. And so some additional details are, there is a blog post on htools.org, and there is a GitHub repository with this, with SANE, and my contact details can be accessed on this website, 5y.io. Let me see if... Okay, I'm seeing the chat.
All right, that was
Maybe
that was awesome.
I
I don't think so. No, I think people are excited. I think we're all kind of getting it. But one way it was phrased by Paul Webb, right? Maybe so. This is like fingertip, but lighter. Is that a fair?
Yeah, exactly. It's that it can be. It can be added to some browsers or to some I don't know, mobile devices. So yeah, it's even lighter than a fingertip.
Okay, fantastic. All right. I know we have a lot of enthusiasm, but we have Alex right here who's got any other burning questions we want to get out in front of him. Paul's excited. Yeah, we have about 9 minutes, so we should, I guess, when Rithvik, who does Alex work for?
For myself, I guess.
Yeah, Alex works for Alex. Good. All right. Release date. Okay. This is a good reminder for me to run fingertip, I guess, for those of us who are maybe lacking on the technical side or a little bit behind or just trying to mentally catch up here. If you want to resolve Handshake names on your computer, fingertip is available. You can install it and use kind of the browser of your choosing. So what would be the best way for the community to be supportive, Alex? How can we help you?
I think it would be good to host some of those external services that provide those proofs, and maybe to have, I don't know, some testing and to have comments and code review. It would not harm for sure. Because, for example, myself, I would not, I don't know, bet all my life belongings to the current implementation. So it's highly experimental, but it runs more or less fine.
Okay, fantastic. Okay, looks like Paul Webb is volunteering here through who are running these services. Fantastic. So he would like to help contribute there. And I think you had shared on the screen the links. What is the best way to connect with you? What are you actually on? Are you on Twitter?
I guess you can connect on my Telegram. Should I write my handle? I hope. Okay, so it would be just random login.
For a naming community, I think it's fair to say that's a pretty cool name. All right.
And let me just, in case, post a link to the repository. And some other link, it was about blog post. Actually, I think there will be another blog post about setting everything up, more detailed.
We did have a question in the QA here from DJ. So as this becomes available for different browsers, will it be up to users to download the patch to be able to resolve? If so, maybe a good tagline would be good, like when Hotmail came out with the messages.
I'm not sure if I understand the message.
So I think, so as this becomes available for different browsers, so this, I'm going to dumb it down here for me at least. This is going to be installed on the device itself, whether it be a mobile device or this runs in the background. It's not integrated as part of any specific browser.
No, not yet, but I think the talks about integrating it will be more active after we have a release. After we have a public release, and it's still a lot of work to implement it inside the browser. So yeah, it certainly can be done, but not that fast.
Mm-hmm. Okay, and again, pardon my ignorance on this, but when certificate authorities give us the lock icon on the top left, is there anything that's going to be telling a user that they are using, that this is their security mechanism?
Well, actually, you will have your own signed certificate, so you will be acting as your own certificate authority. And so once you run for the first time, you have generated your own certificate and you add it to your browser. And so any website that is compliant to this protocol will have just ordinary lock icon, and you will see that it's secure. And when you will use the browser that has internally this stuff, you will just browse as is. You will not have to add anything.
Okay. All right. And I mean, Rithvik asked for a date, but I think we just need to stay tuned. To be determined. That's the date for now. But this is very exciting. Make sure we copy these links. We'll get them out and reshare them. I'll post them since apparently we don't tweet anymore. Fantastic. All right. What else do we got here? Just a couple minutes left. Any final questions? Any other thoughts? Maybe your thoughts. How do you feel about Handshake? You've been very close to it, up close and personal. What are your general thoughts on the space?
I don't know. I'm quite sporadically active in the Handshake community and its development base, so not have that much to say. But I generally think that it's a very nice thing to have an alternative. So yeah, that is.
Okay. And do you think that the value propositions of Handshake have changed since launch? Do you think that most of the infrastructure is still there and doing what it's supposed to be doing, or has your opinion of it changed since 2020?
Not quite sure.
Nah, all right. Fair enough. Maybe I'm the one thinking about it 23/7. All right. Fantastic, guys. Well, everyone, if you need a quick break before the next session, this might be the time to hop away from our computers. I'll be posting those links so we have them. We got the Telegram. That's a pretty good name. I don't think anyone's going to forget it. And we're looking forward. Thank you very much for the time, Alex. We're looking forward to the next session. We're still got one day ahead.
Thank you, guys. Thank you, everyone.